So good afternoon. Welcome to this session on using Amazon CloudFront and AWS WAF and Lambda Edge to keep spammers out. Really nice to see so many people. My name is Anders Bjørnstad, working as a cloud evangelist for Webstep out of Oslo, Norway, working across the Nordics in Europe and also through Europe sometimes. I'm also running the 4 AWS user groups in Norway, helping organizing that. So really like to share my experiences with you guys here. Actually my 8th time at reInvent. So remember back to the first one with kind of 6,000 people here at Venetian. And now it's a massive crowd here. So thanks for joining this session. I'm going to talk about some experiences I had with a system I'm helping running, and also some of the mitigations we did with that system when we got problem. So first I'll talk a little bit about the system and the processes we have. Then the problem we faced suddenly. Diving into the AWS services we used to mitigate things, the mitigations we have, and also the next steps I see we could apply to our system. My background is I'm a technical guy, worked with systems integration for years, software developer, started working with AWS technology approximately 10 years ago. So I have fairly good understanding of the different services, but focusing most on the development services as well as architecture and things like that. The customer case I'm going to talk about today is a system I'm helping an organization operate in AWS. It's a non-profit organization, voluntary working with that. But it was kind of an eye-opener with what we faced, so I'm going to use that as an example now when we go through the different things here. As mentioned, it's a non-profit system. It is a system with kind of blogs. It has content, it has discussions. Users, registered users can add content, photos on various topics. So this is just an example like a trip report or whatever description of Easter Island and someone just writing about a nice experience there. Then users can add comments and also comment on different content. So it's a mix of user-generated content and discussions. At the bottom here, you can typically see what we're facing now and then, and that is spam bots or actual people trolling. So we're facing this problem because we're not using kind of any third party for driving that and checking that. So that's the system. From a user perspective, if you want to register here, it's fairly easy to register. You need to add your email address, and we also have a CAPTCHA here, so just to keep the worst spammers out, or we also have the option of adding a question. So since this is a local system up in the Nordics, in the Nordic languages, we actually found that having some questions in a local language with some local topics was actually better than CAPTCHAs. So normally we're using questions like what's the 3rd largest city or what's this and that from a local point of view. The email address is used for verification of the email being entered, and the user have to click a link like you're doing on other places to get the email verified before it's registered as a decent user in the system. Then behind the scenes, the user is registering on the sign-up page. An email confirmation is sent to the user. The user confirms the email, and then a moderator or an administrator is notified of there is a new user in the queue to be authorized and moved into the regular users group. The admins get information about the username, the email address is visible, the IP address with links to external systems, so you can actually check kind of the geolocation of the IP address. And we're also getting a reputation score from some third-party vendors who are checking IP addresses and email addresses and telling us whether it's a great likelihood of being a spammer or not. Then the administrator is rejecting or approving that user, and a user becomes a regular user in the system, which can add content and can also answer and discussion threads and things like that, and also start separate discussions. Then a little bit about the timeline here. Kind of operation is normal. The system has been running for a long time, so nothing new to that. It's barely no operational burden on the system, even though it's kind of a legacy system in the way it's built. It's an off-the-shelf product. So legacy-wise, it's typically it's PHP, it's MySQL, and other components in there. Off-the-shelf basically means that we're installing the package, and there is very little things we actually can tweak in the system. It has a plugin architecture, so there are certain places in the system we can actually do plugins ourselves, but I'm not really a fan of that because normally it's not in the right places, and it's kind of hard to get it right. Since it's also based on PHP, we can actually go in changing code. There are some templates we can change, but then patching starts breaking. So when we're getting security patches and stuff like that, we have to apply things manually, which I'm not a fan of. This has been running for years and years and been patched through the years and running on-prem, but then we had GDPR and other legislations coming up, so we needed kind of to get a stable hosting provider for this application. So we moved it into AWS some years ago, basically a lift and shift operation, and it runs only on an EC2 server. So we just lifted it into AWS, migrated it out of VMware on-prem. We're using Amazon CloudFront as the first point of contact for the client, and then we're routing most of the traffic to the EC2 instance. If we have failed requests or people are asking for a path that with non-existing content, then we're routing that to S3, and we have all the different error pages in S3, and we also have some static content in S3. So it's a very, very easy setup. We also have some other bits and bobs in the account, of course, to help on the operation side, but that's irrelevant in this case. CloudFront is also used for caching, so great portion of the content here can be cached, and that also works well for us. So that's kind of the setup of the system we have. Then just adding some information about CloudFront here. CloudFront have kind of three different things when you're looking into CloudFront and setting it up. First, mentioning origins. So in CloudFront, you're defining origin, and an origin is actually where the request is going to the backend and fetching content and send it to the user. So in our case, we have two origins, one EC2 and one S3 server. And in the origins, you can say that kind of what protocol you want to connect with the backend, what path you're going to send to, sorry, not send to here, what path the origin is answering on. So as you're seeing here in the S3 example number 2 here, it is in /user groups. You have the content, so that is a prefix in the S3 bucket. We can also say that we only want to connect to the backend through HTTPS. So that's one thing we have to configure in the system to get it up and running. When we're getting connections into CloudFront from the user, the other thing we have to set up is behavior. We have two origins, and then we can set up patterns for the paths coming in, and send that back to the different origins. So in this case, we're saying that /server content /star will go back to the server, my own server. And if we're not getting a hit here, we have a default path which goes to the S3 service. Also, in the behavior, you can set up if you want HTTP, HTTPS, both of them, or in this case, we are redirecting HTTP into HTTP requests. So we're only allowing HTTPS requests in here. Forwarding a query string to EC2 and not doing that to S3 because we don't need it. So now we have the behavior and we have the origin. And then when we're setting up everything in CloudFront and stitching those two together, that is called a distribution. And in the distribution, you're setting up like your CNAME. In this, here is www.example.com. You're setting up kind of the TLS search for HTTPS. You're setting up error handling. So if you're getting an error from the backend, you can send that request to another origin. Logging from CloudFront into S3, access and security and other stuff. So that is the CloudFront distribution. And it's fairly easy to set up. If you haven't used CloudFront in front of your HTTPS facing services, then start using it. There is a lot of advantages there. I also mentioned that CloudFront can do caching. When you're setting it up initially, my recommendation is turn off caching until you know what you're doing. So we're not starting caching content, which is restricted. So every logged on user is getting the same page saying, hello, Anders, even though it's another user. Back to our system. Suddenly, something happened. What's going on? We had a huge spike in registration of users. Normally, we had a user a day, or maybe only once or twice a week. And suddenly, we saw that the queue for the admins to accept new users were growing fast. And I think we peaked at around a new user per minute. The users couldn't do anything in our system, but since we had a manual process, it's kind of made a lot of noise for us. And it also was adding users to the database, which kind of wasn't accepted yet. So it put a lot of rubbish in our database. So we started looking into that, and having run the system for a while, we don't need machine learning to look at some usernames and emails and see that this is not a genuine user. There was a repetitive pattern in the user data, the data the user entered. Lots of the users were flagged as in the bad reputation list we had in the system. And a lot of IP addresses from Russia and Ukraine. So most of the IPs were from Russia and Ukraine on this one when we first took a look at it. So we were running with this kind of localized question, and we switched to CAPTCHA. And that had absolutely no effect at all, not what we could see. The users just came running into our system. So then we kind of had two options. Should we shut down registration of new users and just say, we don't want any new users here? Or should we try implement some mitigations? And kind of since I'm doing this as voluntary work, and it was on a Saturday, I was at home, and I had a couple of hours available, I thought, well, I'm going to fix this. We're not going to shut off registration, and I have time to fix it now, so I will just let the spam bots keep going, because then you're getting data. If you're shutting them down, then they might disappear, and then you kind of don't have any data points. So the first thing I did was basically go into CloudFront and apply geo-restriction. A geo-restriction in CloudFront is either a whitelist or a blacklist. It applies to the entire distribution. So when you're turning that on, it applies to your entire website. You're adding countries. And in this case, we said we're blacklisting Russia and Ukraine. It returns 403 if you're blocking users. And from the documentation at AWS, they say that the list of the geography here is based on third party, and it has an accuracy of 99.8% overall, but it varies by region. If it doesn't find any geography on the IP address, it just lets the user through. So good, fine. I switched that on. That was fairly quick. So CloudFront, geo-restriction, hitting save on that. And those of you are using CloudFront now, know that it's time for a cup of coffee when that is being applied, because updating CloudFront normally takes 10 to 20 minutes. So waiting for that to be applied, and then sitting down, watching the logs and seeing what's happening. And what we noticed was that we had approximately 50% reduction of the registration, but it was still noisy. Since we got rid of all the Russian and Ukraine IP addresses, then I started digging into the other IP addresses because they were coming from all over the place. And I saw, guess, 30–40% was kind of Tor endpoints, and then, of course, other IP addresses here as well from all over the world. The disadvantage we did when we added geo-restriction here was actually that we were blocking legitimate traffic from Russia and Ukraine. We don't have much traffic from those countries since it's kind of a Nordic system in local language, but we do have users there. So kind of, let's see if we can fix this even better. So then I started thinking of what can we start adding to the system now. We tested out CloudFront, and we need some more things to work on. Then I was thinking about the web application firewall. I had been testing that on the system earlier, but we didn't kind of achieve a lot with that. We didn't get any hits on standard rules, so we disabled it, and that worked well. But I started diving into that. And the web application firewall also has some concepts here. It has rules, it has regular rules, and it has rate-based rules. And what I wanted to look into was the regular rules. For example, a regular rule is that it can check one IP address, it can check headers, it can check content, it can see if there are some kind of SQL injections and stuff like that. So rules and web access control list. And a web access control list in the web application firewall is basically a collection of rules you want to do something with. And when you're talking about doing something, something is actions. So you can say that I want to block something matching a rule, I want to count it, or I want to allow it. And normally, when you're setting up a web application firewall, it might be wise just to count the hits on the rule, because then you can check how many times it's being hit, and you can also see if you're kind of in the range you want to do, so you're not blocking anything unnecessary. So looking at the web application firewall and the access control list, it looks more or less like this. Again, example from the documentation here. You can set up one rule saying that if the reputation comes from an IP address and if it contains a value, then block it. Or if the rule looks like it has a SQL injection, then we're letting it through, but we're counting it. So you can add multiple statements to a rule, and they are added, and you can take OR on multiple rules. Web application firewall has also a pricing structure, so take a look into that when you're setting it up, as a lot of the services might be a bit kind of hard to really grasp when it comes to what will the actual cost be. You're paying per web ACL. That's, I think it was approximately $5 per month. You're paying per rule in the web ACL per month, and then you're also paying per million requests. So if you're having a lot of traffic and you really just want to apply a lot of rules, you will definitely see it on your bill. So kind of dive into it and analyze it and see what you want to do. Especially if we had to do that since it is a non-profit and they don't have tons of money. So web application to the solution, I think. Then I could start writing CloudFormation to apply it, of course. I'm always doing that, trying to do that when I can. But there are something else we can use when we want kind of proper solutions from AWS, which is not a service, and that is AWS Solutions. So if you're going on the aws.amazon.com/solutions, you can see a lot of solutions. So I just went in there, typed WAF, and then we have AWS WAF Security Automation. That might come in handy. The security automation contains a list of various things for the web application firewall. It contains a manual list of IP addresses, which can be a blacklist or a whitelist. It has some rules for SQL injection and cross-site scripting. It has mitigations for HTTP flooding, scanners and probes, IP reputation lists, and bad bots. And we had a lot of IP addresses coming in from Tor endpoints, so IP reputation list might be the thing we're looking for here. Diving into the documentation, then it says IP reputation list is the component where you have an IP list parser Lambda function, which checks third-party reputation lists hourly for new ranges of IPs or blocks of IPs and add it to your firewall and blocks them. And Tor was one of the lists there. So going to the solutions page, firing it up with CloudFormation. And there are already CloudFormations there, so you can start it up fairly easy. There are also documentation white papers explaining the solution, the architecture, how you should deploy it, and stuff like that, in case you're wondering. And of course, you can start digging into the code because it basically pulls things from S3. And a lot of the solutions are also in GitHub in case you want to fork it. So good firing up this solution. Again, CloudFront, blocking Tor nodes, pressing save, time for another cup of coffee while it's being updated. And then when it's done, letting it run for some period of time to get more data points to see if it works. The entire AWS WAF security automations from AWS Solutions looks more or less like this. So looking at the drawing here, you have all the different things like whitelist, blacklist, and so on. You have the IP reputation list with the Lambda function. And that is triggered by CloudWatch once an hour. Do remember when you're working with CloudFront, being the WAF, being certificates, being stuff like that, you have to deploy it in US East 1 to be able to hook it up. AWS WAF is also available in other regions because you can hook it up to other services. And typically, normally, you're sitting in another region, a lot of us are, and then you're starting up there, and you can't hook it up, and you have to tear it down. But been there, done that, and probably some of you as well. So setting it up, and this is basically how it looks when we're just setting up the reputation list, because there are options where you can switch on and off the different rules. Valid users are getting in through the WAF into CloudFront, and then, in our case, EC2, no load balancer, and traffic is flowing past that. Then we have CloudWatch hourly, triggering a Lambda function. Lambda function is pulling third-party reputation lists, adding it to the IP set in the WAF, and all of those IPs are blacklisted. The IP reputation list comes from 3 sources. It comes from Spamhaus, drops, and eDrops lists. It comes from Proofpoint's emerging threat list, and they also have Tor exit nodes, which is good. And as you're seeing on the example here, you can dive into the console. Or of course, you have APIs on various services as well, but the console gives a good view here. Approximately 2,500 IP addresses, or IP addresses, IPs or ranges of IPs, as you're seeing. There are /21s, even /19s here, and also /32. But it's updated hourly, and it adds and removes IP addresses, so it's a very neat solution. So again, this has been applied, been saved. We're sitting there waiting and seeing if things are getting any better. Unfortunately, Still not good. We have blocked Russia, and we have blocked Ukraine, and we managed to block the Tor nodes and a lot of other nodes. But we're still getting registration from random IPs around, and the rate is still annoying. And this was at the time I said, I really like to fix this. I've gotten so far, so I reduced it with 70%, but I'm going to stop this. So it's time to think. We need to blacklist more, but what could we blacklist here? And it's also about I'm saying to being out to helping customers, stuff like that. Sometimes you have to take 2 steps back and you have to analyze the situation and see what problem are you trying to solve, and then seeing if you can find a solution fitting your needs. So I was trying to think and analyze the data coming in and see, could we find something to blacklist here, which we could add to the firewall to get rid of the last 30% there. Again, back to the security automations. We had a list with a whitelist, blacklist, SQL injection, cross-site scripting, flooding, scanners probe, reputation list, and bad bots. Bad bots sounds interesting. Bad bots is the component that automatically sets up a honeypot, which is a security mechanism intended to lure and deflect an attempted attack, is what the documentation said. So that's what I'm trying to do. So let's see how we can use the bad bot to block the rest here. The bad bot works in this way out of the box. You have your CloudFront distribution with a server or a load balancer or whatever with some content in a web application. When you're setting up the bad bot, you're trying to get a request not to the web application, but into the API gateway, which triggers a Lambda function. And the Lambda function is adding that IP address to the bad bot list. So in a typical case, you're setting up a web page. You're putting a link on the first page saying /secret.txt. And then you're just hiding a link so it's not visible in the browser. And then you're setting up the CloudFront and API gateway to send that path into the API gateway and into the Lambda function. Also, the documentation says what you typically want to do is also add it to robots.txt, so it's not scanned by Google and others. But of course, robots.txt is not honored by bad bots. So we have this solution, and then how can I send the users into another URL here to trigger this thing and add the IP address automatically. So what we need to do setting it up, as I said, we need the API gateway for the honeypot. We need the IP, add the IP to the blacklist. And the IP is blocked. And this is just a code snippet from the Lambda function, so it's not really much code. And when you're adding the IP address to the blacklist in the web application firewall, normally when you're sitting browsing, clicking yourself, you are blocked on the next request. When you're adding that. So it's fairly efficient. So what should we add? And do we have more tools in our toolbox here? Thinking back to what we have in our system, we have this scoring model for emails and IP addresses. So if we could use that system to get a reputation for an IP address and an email, and adding that to the system, we could use those IP addresses, which are flagged, and add it to the firewall. I could set up a script harvesting all the IP addresses, but of course, the third party is saying that you will be throttled, and you're not allowed to do that. Also, the list is changing all the time, so I had to make some solution to also remove IP addresses. And sometimes we're seeing that the IP address is not flagged, but the email address is flagged, so it wouldn't solve that problem. We could check on every request when we're getting a request to the system, or we could just check on registration. Because the thing is, I don't need to block the users if they're reading. That's fine, but I don't want them to register. So let's see if we can check on registration when people are registering in the system. So my hypothesis was that we could make a possible solution with this badbot thing in the firewall. When the users are registering, they're doing a post with a registered PHP, for example. And if we could check for reputation when they're doing a post, then we could redirect the user to Honey HTML instead of letting them through. And if they have an OK reputation, then we could just let them through CloudFront. And that's where Lambda Edge comes in. Because the users are doing a post on a certain URL, and when they're doing that post, I have the email address. I don't have the email address when they're doing regular gets on the system. So if we could add a Lambda Edge, checking the IP address and the email address, adding that to WAF, then we might be there. Then a little bit about Lambda Edge. First time I used it was actually in production-wise, was in this system. It's a feature of CloudFront, but it's regular Lambda functions. It executes at the edge, so it doesn't execute in the region. When you're configuring it, authoring it, working with it, you have to operate again out of US East 1. It operates both on HTTP requests and HTTP responses. And it can also operate on the body of the request. So kind of for guys like me working a lot with Java earlier, it looks like good old servlet filter style thing. It has limited runtime support, so Node.js and Python. And actually, when I was setting this up, it was only Node.js that was supported, but I'm fine with that. So take that into account as well. Also, using it, it has a different, it's the same pricing model, but different prices than you're having on regular Lambdas. It's a bit more expensive when it comes to the request and the use, but it's metered at 50 millisecond intervals. So a slight change there to regular Lambdas. Lambda at Edge event triggers, as I mentioned, it triggers on request and response, and you can intersect it both on the viewer side and on the origin side. So when you're getting a viewer request in, you can take a Lambda there, and you can check it, and you can do something with it before it hits the cache in CloudFront, or you can let it hit the cache, and if it goes to the origin, then you can start dealing with it, and you can do the same thing when things are getting out. So there's a lot of cool cases for Lambda at Edge, and then we want to apply it to our solution here. If you are using Lambda at Edge and you want to access the body, and we're doing a post, so we need to access the body, then there is a separate option for that, which you have to tick. And in the documentation on Lambda at Edge, it actually says scenarios you might want to use this feature for is processing web forms, like contact us and things like that. So probably a good match for us. Setting up Lambda at Edge, you need to deal with IAM, as you're always doing in AWS. IAM all over the place with roles and policies and also service roles. Comparing it to regular Lambdas, you have to add edgelambda.amazonaws.com to the trust policy to get it to work. Otherwise, it won't work at the edge. Debugging and testing Lambda at Edge is done through US East 1 in the console, for example. So you can see it and debug and test it there. But then it's only running locally in US East 1 as a regular Lambda function. You need to deploy it explicitly into CloudFront. And when you're deploying it, you have to make a version. You can't deploy latest, and you can't deploy an alias. So you have to deploy a specific version. So you have to version your Lambda functions. Then, the more tricky part. You're distributing it on CloudFront, and then, of course, logs start pouring in all the different regions, close to the Lambda function. So I was setting this up and seeing what was happening, and probably might have some bugs in the code as well, which was working when I was running it locally, but it might not work when it's running on the edge. And then kind of sorting out where it failed and not, then you're kind of diving in CloudWatch logs a lot around. Also for metrics, they're not out of the box in the Lambda dashboard. Either you have to go in CloudWatch in each region and look at metrics, or you have to go in through the CloudFront console to see if it has invoked and failed and stuff like that. So that's kind of the different from regular Lambda function. Then I was sitting, peeking in the logs, seeing if it worked, if it didn't work, and yay, seeing some logs in, for example, in Frankfurt, which is in Europe. And then I was sitting watching Ireland, and I didn't see any logs. And then suddenly I was seeing logs in London, and so on. So after a while, I found out, and this is kind of pure me testing it, that these are kind of the regions which are the parents of Lambda at Edge, based on what locations the users are hitting you in. So typically in Europe, where I'm based, Frankfurt is getting a lot of hits, but you're also seeing it all over the place. I've not seen any logs in these regions, and I've not tested these ones. So just have that in mind if you're looking into Lambda at Edge. My view after playing around with it, it has some advantages, of course. It can operate on both request response. You can apply it after or before caching and routing and stuff like that. You have kind of the viewer origin thing I told you about. It has some limitations in my view. It's only Node and Python, so you're limiting to that. It must be deployed in US East 1, and you're kind of relating a lot to US East 1. And I know a lot of customers, at least outside the US, who don't like to operate a lot in US East 1 due to legislation, but this is the case here. There are no cross-account triggers, so kind of CloudFront and Lambda at Edge have to live in the same accounts. And you can only trigger numbered versions, as mentioned, no latest, no aliases. And advantages and limitation is one thing, drawbacks is another thing. So kind of distributed logs and metrics is kind of a drawback. I would prefer to get everything consolidated. There might be some tweaks or some easy way to do that, but I haven't done that yet. It's harder to track down errors because you kind of have to deploy it out to the edge and you have to wait for something to happen, and you can't really just test an edge location in a region. And when you're deploying it, it also takes time to deploy. So you might operate with different versions in different regions. If you're sitting developing stuff, if you're rolling out a new version and you suddenly need to do a change and another change. So actually at the time I think I had 3 different versions of my Lambda function running. So then you basically just have to sit down and wait for things to stabilize. And the documentation says it typically takes a few minutes, but it can take up to 15 minutes from your deploying until it's actually running out there. But you don't know. So it's hard to know if the versions out there are in sync, and also mentioned earlier, price is higher than regular Lambdas. So the solution using Lambda at Edge. What we looked into was using Lambda at Edge to check IPs and emails. So I just made a Lambda function. First of all, we were just checking that it was a POST request, not a GET request, and that we had the parameters needed. So we had the email address and we had the client's IP. Then we were just doing a GET from the third party, getting the payload. And we just said that if the IP is there or if the email is there, then we're treating it as a spammer. And then we're just returning a trap response. And if we don't find it, then we're just returning the request, which means that the request is passed down to the origin. The trap response is this one, 303. So it's a redirect. So we're just sending a redirect back to the client, redirecting to the honeypot HTML. And then the browser will hit our API gateway, which sits behind honey HTML. Then to invoke the Lambda function, because I didn't want to invoke the Lambda function on all calls at server content. So then I added an origin, a behavior. I had the origin, but you can use the origin multiple times if you like. So you can tweak this, but setting up a new path for server content register, PHP, and on that path, you can hook up a Lambda function. So actually, a Lambda function will only trigger when I'm doing register PHP. You can configure it in Lambda. So when you're sitting with a Lambda function in US East 1, you can just say deploy to CloudFront and drop down with the distribution, cache behavior, what kind of event you want, include body, and so on. And if you're in the CloudFront console, you will also see what Lambda function is hooked up and how it is hooked up. So now the solution starts looking like this. We're having the users, and the users have a bad email, of course. We've hooked up Lambda Edge. And when the users are pressing register, bad email will go into Lambda Edge. You will look up if it is bad or not. It appears one time. Then Lambda Edge will return 303 back to the client. Then the client will request that URL from the API gateway, which is the Lambda function, adding the IP address to the AWS WAF. And it returns a welcome HTML file, content back to the user, so the user thinks everything is okay. And the next time the user is hitting our CloudFront, they will be blocked. And as mentioned, it takes seconds. So that was the solution. And then again, did we achieve what we wanted with that? Actually, we stopped all of it. After a while, after running this a while, we had 1,300, 1,400 IP addresses from that bad bot solution. But we managed to stop, I think, 97, 99% of it. We still have a few getting through because they're using email addresses and IP addresses which are not listed yet. But that's kind of a volume we will have to accept. So the system is up and running, and we're back to normal operations in our system. Current state of our system now is we're back to normal. We turned off CloudFront GeoBlock because I wanted to let users from Russia and Ukraine getting into the system. And we saw that the other solution was blocking what we wanted, so we didn't get any rise in user registrations when we lifted that ban. Approximately 2,500 from the general reputation list, and 13, 14, 15, I think we might be up in 1,500 now. This was a couple of months ago on the bad bot list. So everyone is happy, and the system is working as expected. The nice thing, though, is kind of how long did it take to fix this? If you're taking away updating CloudFront, and if you're taking away kind of waiting to get samples and checking it out, it took me longer to make this presentation than doing the solution. Doing the geo restriction is 2 minutes. Setting up the WAF blocking with Tor is kind of 10 minutes. Building Lambda Edge and pushing that out, let's say 45 minutes, because I tend to kind of just hit some code in there and we get some bugs and you forget something and you have to deploy it and stuff like that. But more or less an hour's work with some wait time in between, which I think was awesome. It costs us some dollars a month, but it's acceptable, so we're still running with it. This is the current setup now, so we're using the IP reputation list. We're using the bad bots, which are using the Lambda Edge and the API gateway and things like that. So it's up and running, and we're back to normal, and everyone is relaxing. And it was kind of nice just seeing how smooth it was to get it up and running. Then I thought about, well, we need some next steps here. I haven't had time for that because I wanted to make a presentation instead of fixing my backlog. Lambda Edge, I want to look into consolidating logs, consolidating metrics, so I have a better operational view on that solution. When it comes to the bad bot list, I'm just adding it to the WAF now. and it stays there. So what I've thought about is if I'm adding the IP addresses to the WAF and then also adding it to DynamoDB with a TTL, because in DynamoDB you can set a TTL on an item, which means that when the TTL is reached, the item is deleted. So if I added the IPs to DynamoDB and I said, I have a TTL of 3 months, let's say we want to clean the IP addresses from the WAF after 3 months, then I could just set up a DynamoDB event stream, subscribe to that, and then I could just use an API Lambda function to remove the IPs from the WAF after some period of time. Also, I'm looking into adding more reputation lists because it was fairly easy. There are, for example, some IPs out there, some services telling you if an if an email is a throwaway email or not. So we're seeing throwaway emails, so I can also automate that one. Final notes, analyze the problem and then find a solution. Just don't grab the hammer and run around looking for nails. So I was looking in the toolbox, I was looking at the problem, looking in the toolbox, see what we had, trying to use it a very lean way, simple way. Worked well for me, and it's worked well for me in other cases as well, instead of just panicking and doing something immediately. Remember what tools you have, and also know the tools you have. AWS solutions have a lot of good tools, and as I mentioned, you will find a lot of that in GitHub as well, so if it's not perfect to your needs, check the terms, fork GitHub, do some tweaks, or get some IDs and implement things yourself. And also, of course, know your AWS services and think about external services. Even though I'm really an AWS geek head guy trying to solve everything which is possible in AWS, then don't forget external services. There are a lot of good third-party vendors, services, and stuff like that out there. Then, of course, review and update and look at your solution, because after a while, you might see it was not the best one, so we might want to do something with it. But also, the world is changing. So I'm just sitting, waiting for kind of users to flood in because someone has figured out a way to get around it, or the bots or trolls are using other mechanisms to get in there. So that was just trying to tell you my story, solving a problem in an hour on my spare time during a Saturday where I was doing other stuff at home. Telling you a little bit about other services. I like playing with them, and that's also the reason I'm helping people out for free, these kinds of organizations, because then I can get some operational experience in different fields. So look at that. Also mentioned initially, I'm working with user groups. So I would guess most of you have an AWS user group in a city where you're living or close to you. Check it up, because then that's the place people are sharing stories like that. So just want to thank you for coming, listening to this. I will take questions up here later in case someone has questions, because I know a lot of you want just to run off to line up to the next wait line. I have some stickers, AWS Viking stickers from the Nordics, as long as they last, so feel free to grab one before you leave. Please complete the survey in the mobile app. AWS likes feedback. I like feedback. I want to enhance this presentation as well. So take care and enjoy rest of reInvent.